All right, good morning. Here's a video for the 4.1 notes to kick it off. We'll probably continue with the second part of 4.1 on Monday. We'll go ahead and get started. So what we're going to do is we're going to first start off in staplets. I want you guys to try this out and sort of experiment with it for yourself. So we're going to go to staplets, idea of probability, and we're going to flip a coin and look at the table underneath. So if we come over here to staplets, go to the idea of probability. So here we look at this thing here. If we flip a coin, there are two possible outcomes, heads or tails. On any one flip, you'll observe one outcome or another, heads or tails. Over a large number of flips, the proportion of heads and tails will approximate the probability of each outcome. All right, so what we're going to do is we're going to set the probability of heads for our virtual coin, so 50-50, and we're going to flip it. So we're going to flip it, and then we're going to see a table underneath. So here's my first flip. Okay, my first flip lands on heads, so I have one head, zero tails, so 100% heads. I flip again. All right, now I get tails. So I have one head, one tails, and the proportion is 50-50 each. And if we look at this graph right here, we have our number of flips and our proportion of heads. So on our first flip, we had one head, zero tails, so 100% heads. Second flip, we got tails, so we're back at 50%. Flip again, we get another head, so now we're at 67% heads because there's two heads, one tail. Okay, we flip again, we get a tail, so we're back at 0.5. Flip again, we get another tail, so now we have three tails out of five, so 60% tails, 40% heads. Flip again, we get a heads, 0.5. Flip again, we get a heads. So now we're at 57% to 43%. Flip again, back even, flip again, flip again, flip, 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 flip. We keep flipping. All right. Notice our proportion of heads and tails. All right. And as we keep flipping, okay, we can go forever and ever and ever with this thing. We should sort of notice how as we keep going, the graph gets bigger and our dots sort of approach 50%, okay, 50% heads. All right, so again, we're way off the charts here. We come back, we're kind of off the charts, come back, come off the charts, all right? But as we keep going, okay, 50-50 shot for heads and tails. As we go, we see that this graph approaches 50%. All right, so you play around with that for a little bit. This is called the law of large numbers. All right, this is the law of large numbers. All right, all that is if we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs approaches its probability. Okay, so on this one, all right, we're flipping a coin, which is our chance process. All right, and we know heads is 50%. Okay, so the more flips we do, okay, our heads is going to approach 50%. Okay, so the more flips that we have, our heads approaches 50%. A concept we touched on in the last unit, okay, so as sample size increases, the variability decreases. All right. So let's just say everyone flipped a coin one time, okay? If everyone flipped one time, let's say everyone flipped one coin. All right, we would look at a dot plot here, so we would have our percent of heads. We would have a bunch of people at 100 and a bunch of people at 0, okay? Because everybody flipped a coin, they either get heads or tails, right? And so we would either have all heads or no heads, so 0 to 100, which is a lot of variability, okay? But if everybody flipped 2 coins, 3 coins, 4 coins, 5 coins, okay? The more coins we flip, the more coins we flip, the more that our data, or the less that our data would vary, okay? So more flips All right, the more center the data would be at 50%, right, and the less we would have sort of at the 0 to 100%. All right, now coin flips are totally random, okay? So this is called the idea of randomness. I'm gonna go ahead and erase this, pause the video if you need to. All right. Okay. Randomness is predictable in the long run. All right, but it's not in the short run, okay? So if we toss a coin and get 6 tails in a row, all right, we know in the long run we can predict that it's going to balance out, you know, to 50% heads and tails. All right. In the short run, we cannot predict that the 7th toss will yield heads. Okay, it's unpredictable. Coins are random. Okay, so, you know, there's still a 50-50 shot that our 7th flip will get tails or heads. Okay, so just because we get a bunch of tails, all right, it doesn't decrease the probability of getting tails on the next one, which is still 50%. Okay, in the long run, yes, it's going to approach 50%, which, you know, in the long run, we think it's going to balance out. As we get more flips, there will be more heads to even it out. But in the short run, okay, 6 tails in a row doesn't necessarily guarantee us that we're going to get heads on the 7th toss. All right? So when something is stated to have a probability of X, all right, it simply means that in a very large sample with many repetitions, it could be predicted but not guaranteed. All right. Simulation, we're going to do a bunch of these here. We did a little bit in the previous unit, but a simulation is just when we imitate a chance behavior based on a model that accurately reflects the situation. I'm gonna jump down to the rest of this vocab down here, and then I'll show you on Staplets sort of what we're talking about here. All right, and you can sort of play around with that as you need to. In the previous unit, we used a random number generator. We could also do this on the yellow Inspire calculators, which we'll do for some simulations. Again, Staplets is good for some simulations too. You just have to sort of make sure you know what's what, and this is something that we'll take care of when we come back on Monday, or Tuesday, I should say. So what we can do is in the Inspire calculator, we can randomly generate numbers, which we can do in simulations as well. Not necessary, because Staplets can also handle that. This is just another way to do it. So in the Inspire calculator, if we type in RANDINT, all right, it'll generate random integers. And so in the parentheses, we'll after we type in RANDINT, we should get a set of parentheses, and we're going to type in 3 numbers. First number, second number, third number, with commas in between. So the first 2 numbers are the range. The third is how many numbers we want. So let's say we wanted 5 random numbers from 1 to 50. We would type RANDINT. Then it would be parentheses 1, comma, 50, comma, 5. And when we hit enter, it'll generate 3 random numbers, okay? And then we hit enter again, and it'll do it again with 3 different numbers, and we hit enter again and get 3 different numbers. So if we wanted to get, you know, 20 sets of random numbers, of 5 random numbers from 1 to 50, we could just do that, hit enter, and then hit enter again, hit enter again, hit enter again, and it'll give us sets of, you know, 5 random numbers. So that'll be a good random number generator to do when we have some, when we do a little simulation, and that might be better than Staplets because this one's a little bit more controlled. All right, so I want to just show you a simple simulation real quick of chance behavior based on a model that accurately reflects the situation. So hopefully this will kind of put some stuff in context a little bit. So let's say we go to Staplets, and let's just say we're tossing coins. All right, so one categorical variable. And so let's say we have heads and tails. All right, now let's say we toss a coin 10 times, we get 8 heads and 2 tails. All right, and so let's say this coin is not rigged. All right, so let's say this is a fair coin. So what we're going to do is we're going to simulate a sample count, success is heads, and we're going to hypothesize that it's 50-50. So our hypothesized percent is 50-50. So category to indicate success is heads. Really doesn't matter what we do. But we're going to assume that there's a 50% chance of getting heads, all right? Now let's say we do this 100 times. Okay, so we flip 10 coins, flip a coin 10 times, and we do it 100 times. All right, so here we have five eighths, okay? So based on this simulation, what this kind of says, and again, y'all's simulation may be different, but if we flip a fair coin, ten times, and we do it 100 times, okay? So we flip a fair coin 10 times and we do it times 100, all right? Basically, we have a 5 in 100 chance of getting 8 heads based on this simulation. Again, your simulation may look a little bit different, but we probably should have some on 8 right there if we do it, 100 times. Now let's say we did this 200 times. All right? So now however many 8s we have would be that many out of 200, okay? And let's say we did this 300 times. All right, now we're starting to get some lower numbers. If we did this 300 times, then there's, 3% chance that we get a 9. All right, and there's, if we did this 300 times, there's going to be, 1 in 300 chance that we get no heads. All right, we did it 400 times. All right, and we see that, we get some smaller data points on the outside here. We did 1,000. All right, so we have more 5s. Again, we have some smaller numbers out here. If we did 10,000. All right. Now there's 1 dot on 10, so basically if we did this 10,000 times, okay, based on our simulation, just sort of showing y'all here, there's a 1 in 10,000 chance of getting 10 heads. So you can play around with that a little bit. We'll look at it a little bit more when we come back on Monday and sort of put some more context to it, look at some word problems, but that's all we have for today. So copy this down, play around with staplets if you want to a little bit, and that's all. Y'all have a good 3-day weekend, and I'll see y'all on Tuesday.